Thanks everyone for coming along today. Today's been a busy day for those of us in the Space Industry Association of Australia. We've had a workshop this morning, we've had our executive meeting, we've had our AGM. This is our final event of the day. I won't spend too much time, because you're certainly not going to see me, and I'll introduce the chair of the Space Industry Association, Michael Davis.
Thank you, Professor Andrew Dempster, and thank you to the University of New South Wales for very kindly hosting our annual distinguished lecture and also our other SIAA events today. So tonight is our second annual distinguished lecture, and it gives me very great pleasure to introduce Dr. David Williams. And as many of you know, David is a member of the CSIRO executive team, and he's CSIRO's Executive Director for National Facilities and Collections, which is a role that sees him lead CSIRO's work in astronomy and deep space tracking, as well as computing and supercomputing, research ships, the Animal Health Research Laboratory, and the major biological collections. And he's also a board member of the Australian Academic Research Network. But of even greater relevance to tonight's lecture, he was the Chief Executive of the United Kingdom Space Agency, and from June 2010, he was also the Chairman of the European Space Agency for 2 years. And he was responsible for leading the 20-nation council executive body that oversaw ESA. His academic qualifications are a Bachelor of Science and PhD from the University of Reading, and he's previously worked at the University of Reading as well as in industry and in the National Environment Research Council, as well as the British National Space Centre, which was the predecessor of the UK Space Agency, and also the European Organisation for the Exploitation of Meteorological Satellites, UNSW. He's also been a member of the Global Climate Observing Committee and was elected a member of the International Academy for Astronautics in 2012. The title of David's lecture is The UK Space Transformation, Lessons for Australia. So without further ado, I ask you all to welcome Dr. David Williams.
Okay, thank you very much. Well, it always sounds better when you hear it coming from somebody else. When people say how many jobs you've had, some people respond by saying you couldn't keep any job length. But I've moved around a bit in my career quite deliberately to stay with the subject, and by and large the subject's been environment, the subject's been research. And I put this slide up not because it's got anything to do with the talk at all, not because it's pretty, but also because it explains one of the problems we have with space, which is it's science, but it's also exploitation. And the serendipity sometimes of how things happen. This is an image of the transit of Venus across the sun in 2007, and it's one of those things that you use to measure distances and work things out. But when you go back to history and look at one of the two great things about history, one in Australian terms with Cook, who in Western books anyway discovered Australia, I'm quite sure he did, and you look at the Darwin expedition to the Galapagos, you think that one is science and the other is exploration. And actually the other way around, the trip to the Galapagos Island, Darwin was the token scientist on a mission that was out there to exploit the world of Americas. And because they landed where they landed and he did what he did, it's known as one of the homes of science. In contrast, Cook was sent to the Pacific to measure the transit of Mercury across the sun in order to improve navigation techniques to allow better exploitation, to allow better science of understanding how he did these things. And on the way back, dropped through what is now Australia. And so the two things, one was exploitation and ended up being science, the other was science and it ended up being the exploitation of what is Australia today. UK. So I think when we talk about how things go and how things work, you shouldn't hang up too much of whether you're a scientist or an innovator. You should just see it as a natural pathway and things happen. If we look back a little in history of the UK, I'll work this thing out. There is a bit of a common history between the countries, and I always like to give a bit of context. Now we've got Parks and Geographical Bank, which are pretty much of the same era. I've never looked after Geographical Bank, but I look after Parks. I was there this week talking to staff. You know, in the 50s to the 80s, we had the UK used Woomera for the Skylark rocket launching site, and we had a lot of work there. We still do quite a lot of work there, actually, in the UK, for different reasons. UK was part of the original optical telescope in Australia. It was known as well, it's still known as AAO. Just changed the Anglo-Australian Observatory to the All-Australian Observatory. And we worked together on that. And the guy in the bottom right-hand corner is Harry Massey, who was the first chairman of ESRO, the European Space Research Organisation, predecessor of ESA. The link there is actually from St Kilda in Australia, and moved over to Europe and took over that work. So there's quite a bit of history in the background. And really, when I talk about today, what I want to talk about is why and how the UK Space Agency was formed and what the drivers were. Then just wander off into my subject area a little bit and give some examples of what we did in Europe when I was around in terms of trying to exploit space. It's all about Earth observation because that's my personal field. And then talk about one or two of the things that CSIRO do and give a little bit of a summary. And if you look at the history of space in the UK is one of the few countries that have actually built and launched and operated its own satellite on its own rocket with a satellite that was built in the UK and that was launched from the UK. So I think the UK is in one of those funny places where it's been there, done it, and gave it up in the 60s, 70s. And the reason was that in the 70s when ELDO was formed, the European Launch Organisation, they decided to build the Ariane rocket. The Ariane rocket had a British second stage, which was blue streak or black arrow, I never remember which one. The first stage was a new development. The first stage never worked, so the UK pulled out of launches. And that's really simple history of why the UK doesn't do launches anymore. But the reason that the launch program was built in Europe and why Europe went into it was really independence from the USA. It came about because the French couldn't get a telecom satellite launched by the Americans. And they wanted to have capability to launch. And therefore they built their own, we built our own rocket in Europe and went on with it and could do it. And I think that underpins a lot of the rationale behind the agency. There's a rationale about economics and there's a rationale about strategic requirement. And both need to be in play if you're going to do something. And both need to be important. And in the UK from 86, the British National Space Centre was formed in 1986. It was a partnership across government. There was the Research Council for Environment, the one for Space Science, there was the Environment Department, Department of Defence. There were 4 or 5 departments, and for 25 years they happily put money into different pots. The UK became a member of the European Space Agency, a founder member in 75, and didn't have an agency at the time, and the money came from several sources. And it could continue to come from several sources. But it was, and the partnership with the Space Centre was formed in 86. It was a formal partnership, it had a chairman, it didn't have any staff, all the staff belonged to the partner organisations. And I worked there for a couple of years, and then went away, and then came back and worked there for a couple more years. And went away and came back again and worked there for a couple more years. And we had the Space Agency before I left. So it was really a partnership. And what I want to do is really understand why did it transition to an agency? What were the drivers behind it and why did we do it? And first of all, we have to understand the context of where we want to be. The first one is governments assume if you're a science agency, you do great science. You know, and I say that in Australia, we talk to government about doing excellent science. They just assume you do excellent science. Go to a minister and say, in this area we do excellent science. The most likely answer you're going to get is, well, which areas don't we do excellent science and why are we doing it? So you've got to make the assumption you're doing excellent science. And these are the UK version of challenges of the period early 2000s. Treasury challenges. One is to respond to the changing pace in technology. How can we deal with pressures on natural resources? The UK has, just like everywhere else, a phrase where it doesn't like using the word climate change. It means climate change when you talk about the pressure on world resources. The economic integration now, things become more global. How do you uncertainties around terrorism and security, and demographic change, which is the pseudonym for ageing population. And all those come into play. You've got to be able to respond to these before you can get anywhere with a government that's got these driving principles. And you've got to understand how you respond to that. Because they just assume that good science is things, where do you go? And when we worked with the agency, creating the agency, it came after the 2009 or 8, I can't remember which one, 2009 or 8 ministerial in the Netherlands, where the minister was a Labour person, Lord Grayson. And he was quite impressed by the way the dynamics of space in Europe work, where everybody sat in a room for 3 days. Most of the time was pretty boring, but actually you got the answer, because the ministers were not allowed to leave until they made a decision. And he thought that was great. What he didn't like, though, was that in the UK's case, he couldn't make a decision, because he didn't own any of the budget. All the budget sat behind him in the partners. And it was the partners telling him what decision he could make, whereas the other ministers held the budget. They could decide what decision they wanted to make. So he decided he should change the world and create an agency. He wanted an agency at that point. And we were doing good science and everybody wanted it. But we went on and we had to do a lot of work. And this is probably the slide that sold the agency to government. And it's two things you'll notice about it if you read it. The first is it doesn't mention science. And the second is it doesn't mention space technology. What it mentions the drivers that governments tick boxes for as you do things. You know, the space sector, and this comes out of a lot of work. It's the Oxford Economic Forecasting Study. We spend a lot of money with them. They use Treasury guideline information on how you do things. What happens in the Treasury in the UK, they have a model for everything. If you want to do something with government money, they can translate it to the budget. So if you want to make a better social programme, they'll translate it to a benefit and cost you cash it. An environment program, they'll give you the equation to translate it to cash. So what they do, they take all the apples and pears and they convert them all to bananas. Call it bananas because the answer is pretty bananas, but the relative ranking across them is equal. You have to respond to it. And these are the things, you know, the UK space sector, the calculation we did with the formula they proposed and they gave, and that you use with industry, with the consultants, UK contributed 7.5 billion to the economy, employed 25,000 people directly, 80,000 indirectly. The second line was really good for them. It was a high-tech area. 50% of all staff in space are graduates. Most of them are postgraduates. The value added for employees was 3 times the UK average. The R&D intensity was 6 times the UK average. Growth was 9% at a time when things were static and shrinking. And the share of the global market was 3 or 4 times our GNI capability. And the forward predictions, are wonderful, they always go up in a curve that nobody quite believes and everybody quite works with, but that the business would only get better as we went forward. And it was around this argument that we had to make the case. There was no other argument they would accept. If you just want to do better science, you've got a budget for science, go do it. If you want to do more in the environment, we've got a Department of Environment, go and do it. If you want to do things for defence, you've got a defence organisation, go and do it. The one thing that's not on that chart, which was very important, is the Department of Defence in the UK, Ministry of Defence, and a strategy and a policy that the UK must be able to build its own satellite. It wasn't something they did every day, but they wanted to be able to do it. And the reason they wanted to be able to do it is because then they could at any time call independence into play. They were happy to work with the USA, they were happy to work with ESA, they were happy to work with partners across Europe. What they didn't want it as a kernel, that capability that allows you to do your own thing. And although it didn't provide money for the agency, it took out the #1 pillar of objection. Because normally if you're in government and Department of Defence says don't do it, nothing happens. When they say it fits our strategy, you can get quite a long way down the road with very little. But I think this is one of the key things for me. It was done on this basis. This slide looks simple. I say it probably costs about £4 or £5 million in UK terms to get to over about a 3 or 4 year period. So when I joined the BNSC as Director General in 2006, UK space was in a bad way. The programmes were declining, the budgets were declining, the influence in Europe was declining, the influence internationally was declining, and we had to try and turn it around. And the way we turned it around was not by saying it's important, it's sexy, it's useful, because a lot of people really like space. It was to turn it around and say it really benefits the UK as a country. It really gives benefit So this slide was the way we sold it and the way it worked, and it went through the system, and it took it from the ministerial in 2009, I don't know if it was 9 or 10, I think it was 10. We created the agency on April 2011, so it took about 15 months from when we got the go from the minister to when we became an agency. The interesting thing, in that period, the government changed. So we lost the minister who was promoting it, we got a new minister in, and he saw it, Tory party, cut budgets, slashed things. He saw it and took it on. It became by force. We managed to get it up and running by 2011 in a way which was real. So I think we did it incredibly quickly as a country. We did it incredibly smoothly, and we did it because the arguments were there. Nothing to do with science, nothing to do with what you're doing. It was to do with how it impacts the UK system. And when you look at the way it then operated, and this is an old slide, but it's the slide we had still used, I think. I'm trying to work out how you turn on to the point. The agency itself was only responsible for the technology of space and the building of satellites. We didn't have the remit for the exploitation side. That rested out in the partners. So places like the research councils, industry, on the top there. The partners were who we worked with, TSB, research councils, MOD. They took the information off us and they did things with it. On the other side we had universities and industry who took the information and did things with it. On the front end we have the interface, because we developed programs through European Space Agency, the European Union, and International Space Agency. The UK itself very rarely built a satellite on its own in the areas with telecoms and in broadband satellites. In nearly every other case, we built it cooperatively. So where you don't need to compete, you don't compete. Where you do need to compete, you compete. In telecoms, it's competitive. In broadband satellites, it's competitive. In TV satellites, it's competitive. In environment, it's not competitive. Science is not competitive in the commercial sense. And then on the back, we had what we call the Harwell Space Cluster, and this was the one thing we managed to introduce. There was an existing capability in Rutherford Atherton Labs to do technology. We had the International Space Innovation Centre, which initially was a sort of not very big ESA business incubator, and that's converted now into the ESA Centre. For those who keep in touch with the UK, since I left, we've now beginning to build a new building to take that part on. That will then focus ESA applications in telecoms broadband in the UK, and we have co-location of university people in the centre, so we begin to build a hub up there. And the Technology Space Board, who up here, have also created Space Applications Capital, which is about taking out and doing applications. So behind the creation of the centre was the creation of a model to how we're going to have an emphasis and how we're going to focus things and how we're going to drive it forward. The other thing we did, which is well, what do you do as an agency? What are your priorities? How do you set them? Now, we're still only a $400 million, $500 million a year organisation in a programme at ESA level that's equivalent to about $4 billion a year. So we're sort of a small percentage overall of what the European Space Agency does. We're small, even smaller part of what places like NASA and Japan do, and Russia and China. So where do you put yourself? What you do, you have to look what we call a technology roadmap. You get the community together, and we have 400 or 500 people around the country working in working groups. Quite a big task, all coordinated from the centre. We get 5 areas to look at: telecoms, sensing, position navigation, exploration, and access to space. But there's no real reason why we shouldn't build all because it was sensible. And what they did, they looked at the technologies around the world. They looked at the future around the world of each of these. They looked at the skill base, both present in the UK, and present in universities, and present in industry. And we came up with a roadmap that identified the niches that the UK should go for. And we made it clear that there will be a niche organisation, not a broad organisation. So we focused on instrumentation in space science, we focused on telecom satellites in terms of building satellites with industry. Focused on those areas where we have skills, where we need skills that fit our strategy, that fit the government requirements, and it comes together in basically what sounds like a complicated model, but wasn't that complicated. It was just a lot of information on a page that we assimilated as the agency. And we made the decision on where you go and carry the community with you. this was about 18 months' work in the period when the agency has been set up, completely independent about the economic analysis about whether we should have an agency. This was going to say, what does the agency, what will the agency bring that's new to the world? What will it be that's different from the past? Why, you carry on where you were, so why change? Why not change? So we went down this path, and we went down through this program of identifying key areas, and that's beginning to roll out, budgets become available. And for those who followed again the UK, the day I left, and it was a good way to leave, the UK space budget increased by 25%. That was sort of my parting gift after the ministerial in 2012. Since then, they've got quite a lot more money for national programs. We've got money for the Skylon project for a reusable space plane. That got £60 million. They've got £32 million on the table at the moment for international cooperation. So quite a few budgets have rolled in. They've got budgets which we placed before I left for NOVASAR, which is a novel star system. So the system is beginning to kick in and allow you to do things, partly because you have a rationale that fitted policy, partly because you had a plan that was logical and people could understand, and partly because you had the skills in the country to drive it through and support it, and everybody was on side. So please don't think it's easy. It sounded easy, and it was quite good fun. But it wasn't, I suppose, that difficult technically or intellectually. It was quite difficult to harness the whole system and make it work as well as you went through it. Oh, I think I've got the wrong body now. I thought I should have had another slide, but I'll come back if I've lost it. So what I want to do then is just go on from there, because I think, other than saying that's the agency, and the agency is now embedded, and it seems to be doing well at keeping in touch with people, the agency is now embedded, and what are the real advantages for an agency over a partnership? Well, the main one is its position with respect to government. You're on the top table as an agency. You're not hidden down in the substructure of anything else. You're there talking directly to ministers. You report to a minister. And you have to decide what to do at a political level. So you get to the top table and it makes it work better. It means you can have a coherent programme, so there's no wrangling about where you put the programme. You can have a coherent programme. It means you don't always please everybody, because you can't do everything. But as long as you do it in a structured way, everybody's now happy. They know you're trying to drive in the same direction. And it's focused at where you're getting it. So I'll stop there on the Space Agency in its organisational structure, but I'm happy to take questions on it and work around it. I seem to have lost the slide, but never mind. And we'll go to one or two of the examples. Why is it important in society? And this is why I have to bed down on modelling and observation. But where is the UK strong? Well, we're strong in telecom. We have a telecoms satellite program. UK with France build about 30% of the world's telecoms satellites for everything. So it's a big business. It's a high-tech business. Piece with focus. We build broadband satellites. Very strong in TV style satellites, but telecoms are a difficult thing. We've got a good microsatellite system. Surrey Satellites, which has got quite a bit of money over the years, probably launched. I think when I left, it launched 34 Earth observation satellites, all of them successful. When you think ESA have launched 6, and the weather satellite people in Europe have launched are over 12, and the small satellite, which shows the capabilities there. CubeSats flight in Scotland, flight space in Scotland, and other places now beginning to build CubeSats. So all that's in place. We have a very strong software industry. Software, in reality, a satellite now these days is much more like a jet aircraft. It's a piece of hardware with electronics inside it. So I think the software industry, that's a very silent, but very important place to be. And we have very strong growth in defence because we have a military satellite. But in Earth observation, where has it really benefited in terms of what we do? Well, this is one area. The blue line in the middle is the mean of all the models that people have used to predict sea ice loss. Blue line, the range from there to there is the range of the models. Some models are more optimistic, some are more pessimistic. So they're the theoretical models that come out over time. The little red line is the actual decline in sea ice in the Arctic in the same period. And the thing you can see is that the decline is even out of the most pessimistic or optimistic, depends what you want, model with the likes, the loss of sea ice. And that's really from satellite observation, and that shows up on the next slide. And this is September 79 to September 27. You can see the sea ice in 79 and you can see the sea ice in 27. And that repeats itself on a systematic basis. Sea ice is disappearing over time. And we've done a lot of work on this where we've shown it. But what it shows is that yes, you can have the best models in the world, but actually you need observations to verify models, you need observations to initiate models, you need observations to see whether models are sensible. Satellite data has got a great scope to do that in Earth observation, giving you the spatial data set giving the world. If we look at the value of satellites in forecasting, something like 80% of all disasters in the world are weather related. The only ones that are not are those related to earthquakes. These are natural disasters, we're not talking about man-made disasters. There are enough of those to go around. And the cost of them is enormous, you know. In 1997, France cost them 6.7 billion to store. In Europe in 2003, 30,000 people are reported to have died because of the summer heat wave. And the losses were estimated at 13 billion. And it's not just European, it's all around the world. Why is satellites important in this context? I'll give you nice pictures you see on television. The next slide shows that. These are the 3, 5, 7 and 10-day forecasts. And you can see from 81 to 27, all my work stopped in 27, I have to say. What was the 3-day forecast is now almost a 7-day forecast in terms of quality of forecast. You draw a line across. But the other one is the top and bottom line. This was the northern hemisphere forecast at the top, and the bottom line is the southern hemisphere. Northern hemisphere, southern hemisphere. There's always a big gap. There's always a much better northern hemisphere forecast than southern hemisphere. And the reason is there's no land in the south. It's only really 300 bits, relatively speaking. The north's flooding with land, it's got lots of observations. So the northern forecast was always much better, the southern forecast much worse. And the reason it's closed up, and there are two issues here. One is one of the reasons to improve better observations and better models. So everybody's improved. The reason it's closed up is satellite data. 70% of all data that goes into weather modeling today is satellite data. Satellite data doesn't respect land boundaries. Satellite data just comes in. So the closing in the gap between southern and northern hemisphere, which you can see was quite a big gap in those days, is now down to almost minimal. That's all related to the use of satellite data. As opposed to the change in the shape of the curve, which is as much to do with the way that models have improved in general as well as the better data sets. So you've got two things in play. And that just shows that the satellites around the world are really important to improving weather forecast modeling. And as a result of that, if you go back to the last slide, a great impact on economy. We all want better forecasts, but we don't. The government only want better forecasts that impacts on society. And the problem we have, of course, is the forecasts themselves. We always have a problem. It will rain today, certainly in Europe, and it's a bit like in Sydney, I have to say. One of the things that I get, similarity between the UK and Sydney is the weather's just as variable. The difference is it's always 20-degree warmer in Sydney on any given day, which I really do like. But, when you give a forecast, it might rain today, you might get a heavy shower. A farmer doesn't care whether it's daytime or night time, he's just happy. The person going shopping wants to know, will it be between 2 and 4 o'clock in the afternoon when I go shopping? Forecasts are not that good yet, but they are good for the baseline economic purposes. And that's the big difference in forecasting. We think the individuals, they always get it wrong because it rains on the cricket match or it rains on the rugby. But in terms of what it's written for, it's really quite accurate and really very appropriate. In the UK now, and I think they're going to use it here, forecasts, certainly in the Gold Coast, CSIRO itself did some work on forecasting. And what we did actually was the schoolies holiday and the forecast of how many schoolies would end up in hospital. We got it right within 5 people. We predicted 505 and it was 503 actually ended up in hospital. And you don't think that's important, but it is important because the hospitals then have to they staff up for those particular injuries. And what you can do with forecasts is if you've got weather which is going to be pretty, you don't get much here by an atmosphere, you get more asthma cases. In the UK, when it was icy, you get more broken legs and limbs. So hospitals use it to forecast it. McDonald's use it, believe it or not, to decide how many hamburgers to send to country restaurants. Because they've got a delivery on time. And if it's a sunny weekend, you go out of town and you want McDonald's in the country. If it's a rainy weekend, you go into town and you want McDonald's in town. So their delivery schedules are driven by the weather forecast. Because we're not entirely by it, but you know, they're refined by the weather forecast, which allows them to reduce stock, reduce deliveries, and focus the service where it's needed at that particular time. And that's the way forecasts are being used around the world more and more. But this is a slide that makes you realise, you know, don't always believe what you see. This is what I call the difference between data and information. And I always say you can't have information without a person involved. These are poor chaps, all of them. We decided to literally follow the GPS up in front of them. Connect the next left. There's the bridge. There's the way to the river with the boat. Slipway. There's turn left to the next left, straight down the slip road into the river. You know, you can't believe it, but it does happen. You know, how a lorry, a van can get that far up a country track, and this is what happens if you set GPS to the shortest route, not the quickest route, or main road route. It will send you down little tracks. So you end up there, this one, you know, in the road that just gets smaller, this one. So people, you know, you've got to be intelligent in how you use this stuff. And this is just a slide. Be aware, when you follow your GPS, don't follow it too sluggishly, especially in the dark, because it can send you the wrong way. So, if I turn off the UK and turn back to Australia where we are, because I think I was asked to do something about that. You know, what are the challenges in Australia that we face? And these, they look a little bit like the previous ones. These are the ones that the chief scientist promoted about 18 months ago, on which I understand are still in play. With the Prime Minister's new committee today, this afternoon, these are on the table to be approved by the new government. They've never been approved, but we're all working to them. We're all working towards them because they are actually quite sensible. They allow you to focus where you're going. Living with changing environment, I think you recognise that from the previous one. Population health and well-being. And the reason population health and well-being is important because it presents as budgets the government go on health. Managing food and water assets, Australia's place in a changing world, and lifting productivity. So, you know, if you want to do things in space, you've got to do things around that, and you've got to make sure that you respond to those sort of issues. And in a funny sort of way for Australia, the world's in our hands. We're a big country, we're geographically in a great place. From a satellite perspective, we're where we need to be. You know, it's one of the greatest countries in the world from climate, from geology, from a land perspective. Satellite data. One of the greatest countries in the world to use satellite telecommunications in, because you've got a lot of small towns, very dispersed, putting cable in. Even MBN haven't got very far outside any of the major cities. Haven't got very far in most of the major cities inside them, let alone outside. Because cable laying is expensive. Cable laying is a problem. I lived in a country in the UK and I had a satellite receiver for broadband. I was one of the key people. And the problem that everybody argues about is, oh, well, it's, you know, it's not good because you've got a latency. You've got to come down to 30 seconds instead of a millisecond. But when you do that calculation, there's 2 or 3 things you forget. One is, if you're linking to America or to a different part of the world, you've still got a latency on the ground-based system. They have to be cabled across, they have to be picked up, and there is a latency. The second is that kids are great. I had to have kids playing on it to test games out. They're the things that work. Do games really work. And they get really good really quickly. It's a bit like duck shooting. They learn to shoot in front of the target. It's amazing how kids will do that even on a computer game. They learn to play in front of the game. Just the same way that when you drive, you know, if you just look at the front of the car, you'll crash very quickly. You've got to drive down in front of you, away from you. So it's built into the human side that you can actually manage with latency. And it was great. You'd be in the house, you'd be in the middle of nowhere, you still get a 2 or 3 megabit link. On the landline, you'd be looking to get 300 or 400 kilobits. You're at the end of the line, 12, 15 kilometres from a telephone exchange. So Australia's a great country for all the right reasons. And it's a great location in terms of Asia Pacific, where we've got Asia Pacific we can act as a conduit for Asia Pacific and do things along the Asia Pacific front. We're a great place if you want to be safe and monitor things going on in Asia. I'm not talking myself, I'm talking about agencies that might want to monitor what goes on in parts of Asia. We're in a great location, a safe location. And in terms of places to come and live, you know, there are worse places. You can go to the mountains, you can go to a lot of worse places to live in Australia. And for us, So where are we in Australia? Well, there's no real space business. I would say, if I'm being honest, the space technology industry is not there at all. There's a little bit around CubeSat, but there's not much else at all. Is that a good thing or a bad thing? Well, if strategically you don't need one, it's no problem. I guess there isn't. So where do you need to focus? If you do that, you need to focus on how you become an active partner of the world. If you want to play with the world, you don't own satellites. You've got to be a partner that they want in the game. But that's an asset you can use, an asset you can play with. So what we've got in the UK, the integrated marine observing system, is a cowbow, an ocean, well, a coastal cowbow station that has sensors on it to do water quality, and sensors on it to do various things, and allows a southern hemisphere calibration site that's pretty good and well documented and in a good location. Got a similar one out in Western Australia that's run by CSIRO, and here it's on a salt pan, and this is a salt pan, and this is the variation. This is the broadband, this is the visible near infrared, and this is the mix of the two. And if you look at the curves, through different observations of different satellites, these are different satellites. The shapes of the curves are always the same. There's a bias on each satellite, there's a different bias, but if you check that out, the good calibration site, because the shape is the same. This peak here is just a water vapor band, so ignore that for the time being. What you find though is, of course, if you're using a system that looks right across the spectrum, you lose a lot of detail at the lower end, because the background of shortwave infrared is pretty poor on the south pan. So there are limitations there. But this is quite a good one. It's a good site that we use. We've got a lot of international interest. We've got robots working on it. The Chinese and Japanese are always using it. So we've got a bargaining tool on the table that we can work with. We've got a bargaining tool that can allow Australia to be part of the bigger game and to work on it. And in terms of where we are in applications, I'll just go through two or three. This is a mineral mapping. This is from the ASA satellite, and it was a 20-agency effort led by CSIRO that looked at something like 3,500 satellite images over a period with about 1,300 calibration sites around the country to map mineral mapping. And, okay, I'll leave you to argue all the detail, but the geologists are really quite keen on this sort of stuff. I'm a geologist, but I'm not quite as keen as some of the geologists, but they're really very happy about it. And one of the things you get when you look at it is over time, if you look at these things, on the Coopers Creek in southern Australia, the clay content, clay fractions on this line, you'll see it's very constant across time. The sand content across time has increased, and that's because you've had erosion. And erosion has removed the fine particles, the clay, and left the sand behind. And therefore the sand has become more concentrated, and you've got a higher sand content. So what we need to do is interpret from this changes in the superficial ecology, geomorphology, and the superficial deposits around Australia. And that helps with things like mineral mapping, chasing gold deposits, chasing various deposits, because if the clay's moving, the sand's staying behind, that tells you something about where the minerals are going as well. And if you're writing, if you can work it all out. The same one is on the barrier reef, and this is one that is now in operation with BOM. We're responsible. This is looking at, so that on this, these are just the sides along the coast. These are different areas. This is chlorophyll content. You can see it's quite a big shift in chlorophyll content as you go down the coast. So you've got little peaks in these areas and these areas. Sorry, in this area, this area, this area. This is total suspended sediment, which is quite high when you've got river basins discharging. And this is some arbitrary scale of water quality, which I've not quite worked out, and I was going to explain to me. So we've got a slide looking at that one. But what they're doing is routinely monitoring that barrier reef, looking at how discharge varies. And on the next slide is looking at the whole thing. This is discharge levels over years associated with salinity on the coast. So high areas of salinity, number of occurrences of high salinity. And you can see it's in pockets, it's not uniform along. And this is salinity ingress into the land in times of drought. And its relationship to water. And you see discharge, which is the black line, it's gone up through the years. Salinity is actually staying fairly constant. The salinity ingress is staying fairly constant. That tells you that a lot of the water just pushes straight down, straight into the reef, and doesn't sink in the ground, doesn't regenerate the aquifer, it just basically flows across. So again, through this sort of monitoring, we're beginning to do real things in Australia important, and it's real-time variability in an important variable from a government perspective, from a social perspective, and from an environmental perspective. So what's what you've got to do? You've got to focus on those things. I use the next slide here because probably won't start anymore. That's what I'm going to talk from Ken, but I probably will start. I do like this slide when it works. I'm going to have to make it unstart and start again. I never understood a computer that doesn't have the drivers. You've got the driver on the same machine, so it doesn't work so fast. So, where are we then and really to bring a summary to it, where are we in Australia? And actually not in a bad place, you know. What you've got to do as you progress the support for space is look where you are on the curve of what you might call exploitation, the curve of technology. And Australia's actually got quite a good civil programme using satellite data, using a lot of environment. We're working, Geoscience Australia have done a really good job on something called the data cube, which is not really space, but it's very important. It could be a major tool that could be exported worldwide. So we're doing a lot on the civil programme in terms of how do you use satellite data, how do you make it work. And if you package that right and get it with industry, you can take that and use that as an export service model. So if you go to countries in Asia Pacific, you use the things you learn in Australia to sell services in other parts of the world. And for Australia, that should start with Asia Pacific. And you know, there's a lot of scope to do that sort of work. There's quite a lot of work in this area on satellite debris. There's CRC now on satellite debris run out of from the US. Australia has been very strong on monitoring, using satellite laser trackers to monitor satellites and debris. We do a lot of work on that, which has got a lot more money to do it. And another bit about that, and I was involved to some extent, is the fact that they talk about using lasers to move the debris rather than piloting the satellites. If you can spot it early enough, you can just gently push the debris out of the way. It sounds easy. It's not easy, and could be quite dangerous having a laser pointing into the sky and hoping it doesn't actually just pass an aircraft isn't quite getting the way to do it. It's always going to be quite a tricky thing to do, but these things have to be managed. What are we doing on the international presence?
Well, I think building up, and all I have to do is congratulate the team, most of them in this room. They've now got the Congress in 2017 in Adelaide, International Aeronautical Congress. And that's a signal that Australia is being listened to internationally. It's a signal that people understand Australia. And it's a signal from Australia that they want to be more international. Next year, we're going to do the 2016, we're going to lead the Commission on Earth Observation Satellites. And that's CSIRO led, means Geoscience Australia, and putting people into it, accredited there, to lead on the way that the world cooperates in the use and development of Earth observation satellites. And again, it's a signal that Australia is being listened to, and Australia wants a voice on the world stage. So in these two areas, we're doing well. This is the area that's not really there at all, to be honest. Whether it can be there is a big question, because I'm a geologist, so I'm reasonably relaxed. People in this room have a different view. But that's the area that will be a great challenge, coming in late and picking up on that business, and making that business something real. It's a high-tech business. It's a very difficult business to break into. The CubeSats let you. It is quite a specialist world, but it can be done. Surrey satellites came from nowhere, and now one of the world's top satellite producing companies. There are two companies. There's German companies that's competing heavily with EAS. So, well, that Airbus is an outfall. So in Europe, the model is changing. If you look at the way the world's going to go in the future, weather satellites might be a thing of, certainly low Earth orbit ones, might be a thing of the past in 15 years. There's payloads of opportunity being flown on more and more satellites of any description. And if you can just put a payload of opportunity up, then you can get into the business at low cost. But at the moment, all weather satellites are bespoke and very, very expensive, I was telling you. So the model is changing, and it's changing in the launch world. The launch world until 15 years, 10 years ago was completely government orientated. But in the last 3 or 4 years, it's become actually a commercial business. And the dilemma for places like the European Space Agency and NASA, what are they doing in the launch business? It's developed, it works. There's a limit to how efficient you can make a rocket.
full stop. Unless somebody works out a new way of firing rockets, because the exit speed from gravity in the Earth is fixed regardless of mass. You've got to get to that speed. The ratio between payload and rocket fuel, it works out it's got a peak of about 1.9. They're very close to that peak now. So why develop opportunities? Liquid fuel ones, yeah, they're a bit more flexible. You can change the orbit as you go up. You can inject them into more accurate orbits. But you've still got payload mass, payload to take off mass problem. You can never get around that problem. So the world of launches is changing, and Australia wants to get into this field. It will require a lot of effort. It will require a lot of drive from industry. If we want to be good in this area, it will still require a lot of drive from industry. But I see from what I see in Australia, a lot of those people are around, but it's possible to do that. And there are ways of getting around. And you don't do this unless you've done this. You don't need to be agile in building satellites, so you can build unnecessary satellites. But you can be agile and lean in how you exploit them. From down here, you can move straight to the exploitation side. You have to do two things. The question then is, do you need a new focus to deliver that? And the UK decided, yes, we should have a space station to do that. I'm quite pleased I was around when it was created. I was the first leader of it. So the whole driver for the way the UK works is based on a certain philosophy. I think Australia is in a different position, but it's not that far away from where the UK was in 1986, with the exception that by then the UK should still build satellites. In 86 it was still building satellites. It was still building. So it's quite a challenge if you want to go down that route. But I'm very optimistic about going through the exploitation program and making a strong world there. I guess with that, I just stop talking and I'm happy to take questions from anybody who wants to ask it.
Who'd like to ask the first question?
Yes.
So, would you mind just telling us who you are or who you represent?
Lloyd Wood, doing telecom stuff in Australia now, but spent a long time working in the UK space industry.
Yes.
So the UK space history is quite interesting in that, as well as stepping back from launches, Thatcher made the decision not to set up the space agency that was originally envisaged in the mid-80s. And as a result, that left a kind of gap into which satellite technology and others actually did a number of things that were separate to what was happening in the European Space Agency. Now, given that the UK has had that kind of setback, do you see any kind of analogues with the Australian scenario in terms of lessons that could be learned from actually backing away from setting up a UK space agency and just letting industry do its own thing?
Well, I think, just correcting on the first thing, the UK in 86 had a choice. It was space station or launches. She said you can only have one, so we chose one, the space station. She didn't make any decision on space agency. What happened is that Roy Gibson, who was the first Director General, was promised to work for space agency. When that decision was made, said, well, you're not serious, I'm going to.
Sorry, result, yes.
And Roy's a great guy, and he's still a great guy. But he walked out and said, well, if you're going to be stupid, I'm not going to play the game. I don't want to do something else. And he went off to him also. But he's still around. I've worked with him. Steve and Ruiz worked with him a lot. But that was the background for why, at that time, there was no agency. He was promised it, wasn't given it, so he walked away. But in terms of opportunity, I guess the big change now is the two changes that you've got are small sats, CubeSats, and payloads and opportunity. CubeSats have a problem. The real problem around CubeSat is deorbit. Because for those, and I know more about space law than I ever want to know, but if you actually want to launch a satellite these days, it's got to go into an orbit that lands it deorbit safely. CubeSats don't have a deorbit mechanism, so the compromise has been put in a 250 kilometre orbit, so they drop down quickly. If you want to go higher, you have a problem, and we actually used to refuse launch requests in the UK for CubeSats that wanted to go higher. And the reason is quite simple, is that the space law is the country, not the country that's flying. So if a CubeSat went up, the smashed into another satellite, Australia would have to pay the bill, not the company. So that's a bit of an issue. It wasn't an issue a long time ago when it was in government to government. In a world where the space is getting crowded, it is an issue. And the government cannot get out of that. Right? All they can do is lay it off through insurance. And you can't get insurance against massive, like trying to get insurance. Get insurance about a satellite landing on London would be impossible. But you can get insurance about losing the satellite, you can get insurance about mining to damage the satellite. So I think CubeSats are a possibility, I think payloads of opportunity are a possibility. Because there are two areas you can get into without with the whole game. I think if I was going elsewhere, it would be software design. Software is the hidden gem of space. It's the thing that makes it work. And the other area, which I didn't mention much of, is the ground stations. I guess Australia has a number of ground stations, and I think we're in a bit of a state at the moment. We need to do some work about making sure we have a viable ground network to receive satellite data. So there are areas you can get into, but I don't see a way into launches other than as a partner. The UK going through the Skyline programme. I think we have people, certainly in East from NASA, were surprised when they looked at the analysis of the early research that proved it would work. That's an interesting example. Skylon, for those who don't know, it is a single stage to orbit. It transfers from being air breathing to breathing from the payload, from the fuel on board. The biggest single thing with that sort of technology was what do you do with the energy when you slow, and how do you stop fuel freeze? So the driving technology on that was actually heat exchange. It extracted the heat that you've got to get rid of and kept the fuel warm so it could go in. People say it couldn't work, it's been proven to work. But the interesting thing, the guy who put his money in, put the money in to develop the heat exchange, runs hotels. Because he works out, if this heat exchange works, all my hotels are very cheap air conditioning. It's the same principle. So he was in it for a completely different game, he still is. But because he likes space, he's willing to do the research in the space context rather than just in a local context. It's how it's more fun. So there are ways of getting into this.
You mentioned that, when I was Elias at the time, so I'm a senior lecturer here at UNSW. You mentioned that actually, just to say something else, I'm involved in the QB50, I'm reading the QB50 contribution of UNSW. You mentioned that the UK Space Agency used to refuse, or they still refuse, launches of CubeSats to apply
Not all of them. We had to do analysis and see whether it was going to go into a safe orbit.
Can you please comment on the role of the UK Space Agency in terms of the regulation of...
With space you've got three issues. One is the space up to 60,000 feet is controlled by civil aviation. Anything that takes off up to 60,000 feet that uses aerodynamics to fly is called an aircraft. And civil aviation have authority. If it uses thrust, it's called a rocket. They do it. So if it's a rocket, it was in the Space Agency remit. If it was something with aerodynamics, it was in the CAA remit. From 60,000 feet to 100,000 feet, nobody's in charge. It's Wild West. Civil aviation stops at 60,000, space kicks in at 100,000. In that interval, nothing happens. Beyond 100,000, the rules are clear. The country is responsible for causing damage other than by accident. And basically, you're supposed to license every launch. An instrument should not be launched on a rocket unless the country that supplies the rocket and the country that supplies the instrument support and approve that say it's safe. The laws changed a bit because it was written in the days when actually the people who built rockets and launched them were also the people who built the instruments and launched them. The rockets running in 3 or 4 countries and satellite. It's not really adapted to a situation where you build a rocket, say in Australia, a satellite in Australia and launch it on a Russian rocket. Formally speaking, it's the launcher state that's liable. So, and lawyers would have a field day. Is the launcher state the country with the rocket, or is it the country with the satellite? And actually the launch business has adapted now. Most companies who launch give you, I think it's 60 to 100 million launch liability. But if the rocket fails, then you get your money for a new satellite. And there are funny rules around that. Whether you buy a service where you own the satellite when it's delivered to the rocket, whether you own the satellite from the moment it separates from the rocket is very important. You own it from when it separates from the rocket. If it blows up on separation, they pay. If it blows up after separation, you pay. Take it from when it goes to the rocket, you pay anyway. So those are very, as with all those, lawyers on the field think it's a great place to go into because there's a lot of stuff around the law. And I've done far more than I wanted. What we did, we made sure we employed, we didn't do it ourselves, we had persons after it. We employed people in industry to check the technical specs of the launch. If it's an ESA satellite and it's a UK instrument, not an ESA satellite, you don't need to do much because ESA will let things through. If it's a UK little satellite going onto a Russian launch, we do need to do it. And we did project somewhere they wanted to go into 400 kilometre orbits because they had no way of getting them down safely. Therefore, it would become a liability to the UK. We had other issues around whether you could have shell companies in the UK. Because to launch a satellite, you need a launch slot, especially in geostationary. You need somewhere to put it. Different countries have different launch slots. So you buy a launch, you work out of a country that will give you a launch slot rather than a country that you want to be in. So you've got to stop the old line, it's called the Liberian tanker shipping problem, where countries are convenient for shipping companies that allow bad practice to go. So the UK was pretty strict on it. Other countries are less so. France just say, we'll take the route. The US say, we'll take the route. So it varies by country, but the rules are very clear.
Question up the back.
Yeah, thanks. There's a long history of Britain conducting research on the Australian mainland, usually by exploding nuclear bombs. But not trying to make you feel guilty, but it might help with my question. Is there a possibility that for real sort of joint US-Australian cooperation, because obviously for the same reason that you wanted to let nuclear bombs here, because we've got a lot of empty space and not a lot of people around, that's a big advantage. I mean, obviously Boomerang now, they're doing scramjet tests and other things for those very reasons, because you can, don't worry if things pop off in the wrong direction, because it's not likely to hit anybody. So for those reasons, I can see Australia having a lot of advantages, plus the fact that you're launching in the southern hemisphere, you're talking about clogged orbits, there might be some advantages in launching from the southern hemisphere, and also the fact that there's problems with launching in crowded continental spaces. You've got many countries together, where countries like, say, for example, Africa, might be unstable politically, but you also might have to worry about airspace rights if you launch from a small country to another one. So for all those reasons, I can see Australia having advantages. What is your take on Australia as a possible kind of boutique kind of launch and research centre for those reasons?
Well, I think on launch, it depends where you want to go. If you go suborbital, I think yes. But if you want to go orbital, then the closer you are to the equator, the better. So, you really want to be up at the northern end. For those who are interested, I don't know whether, it's not really a secret, but when I was in the agency, we had to clean out the farms, we had to go to the paper farms and get rid of it. I found a farm from the early 70s, the late 60s, which had no on it. And the no was Australia rejecting Karoo being in the Northern Cape. So the UK had asked Australia, would you like to be the launch site for all European rockets before French Guiana got it? And Australia had said no.
Yeah, it's more to do with the mindset of the Conservative governments at the time.
So I'd say if that's one big missed opportunity, that's the one. And certainly for test flights, lower down, Boomer is still okay for suborbital and atmospheric. So that's all good. But the closer you are to the equator, the better.
So
Then you get a better flight talk off the Earth. But we do work with America. I mean, within CSIRO, one of my areas, deep space communications network down in Kibir, south of Canberra. At the moment, managing every satellite that NASA said to look at the planets around the solar system. And we were the backup We weren't the live site, but we had the live feed. We were the online backup site for resource possessor landing. Because if the other site in Western Australia got down, you had to have a real-time switch over to this site. So you know, Australia is quite big in that area. It's a big site, and there's a slight quirk that the geometry of the solar system is such that for the next 30 or 40 years, Australia is the best place to look at all the planets, and therefore all the satellites are up to. So Australia is actually big in a lot of ways. But you're right, around the big airspace in the middle, a lot of things go on, not really to do with space.
We've got time for one last question. Yes, Josh.
Josh Richards, I speak in schools quite regularly about space and that sort of thing. What's the biggest stumbling block for us to move forward? Because I hear a lot of
Move forward on what?
in terms of developing the space industry. There's discussions about whether or not we should have an agency, whether or not we shouldn't have an agency, all those sort of things.
I think the agency at the moment is red herring. I think at the moment it's what does Australia want to do? What's the benefit for Australia? And I think, you know, if we want to do that, industry has got to be at the table, saying if we did this, industry would be this big, industry would grow like this, it would impact the economy like this. That's because you know about everything. The alternative would be for Australia to say we must have the capability to own and build our own satellite for strategic reasons. They're the two primary drivers. Otherwise, in all the fields Australia is currently strong on the exploitation and use of their space, you can quite happily work with other countries and do good things.
David, for me, the takeout from your lecture this evening has been what I would like to call the Williams curve. And it starts with the civil program and then the international representation and presence, which, as you say, we've managed to achieve very recently. And then the next big hurdle is the investment in the industry, and then the approach, the lean, agile, commercial approach, and finally the new focus on delivering goals. So I would say we're about 40% along the Williams curve, and it's been a great inspiration for us this evening to hear your story, to hear about the comparisons and the similarities between our two countries. But I think it's given us a lot of fuel for thought and also some encouragement in our mission in building a sustainable national space program in this country. So on behalf of the SIAA, please accept this small token of our appreciation, and please join with me in thanking David.